Okay, and let's start sharing the screen again. And I'm going to jump straight to Eclipse. Okay, so what are we going to be talking about today? Where we are going to start with chapter 9, and chapter 9 is all about arrays. So we're going to try to understand what is an array and how do we create arrays, and what is the point of arrays? Why do we need arrays to start with? We're going to see details about arrays, operations we can perform with arrays, and we're going to see there are two very, very important operations that we can perform on arrays, which is sorting and searching. And we will look at a single dimension array, a two-dimension array, multi-dimension arrays. And we're going to see that we have a very, very special loop is associated with arrays. We talked about loops before. We said we have a for loop, we have a do while loop, we have a while loop. And today we're going to, not today, in this chapter, we're going to learn about a new loop that is dedicated to work with arrays. So with that being said, let's jump into what is an array. Well, before I say what is an array, let's just go back to what we have been done so far. So far, if you want to just summarize everything we've been doing at the beginning of the semester till this point, it's just whether it's an object-oriented programming style or procedural style, you're just creating variables and you assigning values to variables, and then you're processing those variables to get something done, to produce some results. And if you go back to everything we did from the beginning of the semester till this point, you can put it under this definition. Have some inputs, process those inputs, and get the results. Now, let's just focus on the input part of what we've been doing so far. As I said, we've been just creating variables. Variable here, variable there, assigning values, asking the user to assign values. And then after that, we're going to use those variables in some sort of operations, arithmetic operations, logical operations. And then after that, we might end up making decisions, doing some calculations, and so on. Now, that is acceptable somehow. That's good. But if you think programming is all about that, then let me tell you, you are wrong. Programming mostly is about processing big amount of data, huge amount of information, especially these days with AI, deep learning, machine learning. It's all about processing huge amount of data to get some outputs and results out of that. Mostly, we're trying to predict something by studying the history of that thing. So basically, if you go, for example, you want to start a business and you don't know if this business will be a success or not. If you have access to all the data and the information about all the companies that are related to that business that you want to start, and let's say you're collecting databases and data structures of information, you can process the information to answer a single question: is this a good idea or is it a bad idea? So what I'm trying to say here is that programming mostly, it's not about processing few variables to come up with some conclusions and some results. Programming mostly, in a lot of application, if it's not most of the application, it's about processing huge amount of data. Now, the question is, how do we organize the data that we need to process in a program? And the question is using something we call data structures. Data structures are simply methods that we use in programming to organize the data. And the reason why we need to organize the data is so we can have a simple, fast access to the data. Efficiency of access to the data plays a major role on the design of that data structure. So we trying here to organize our data in a mechanism that will get the job done in an efficient way. Now, when we talk about efficient way, sometimes we measure efficiency as how long it would take, and sometimes we measure efficiency of how much space it would take. So efficiency again here, different measurements for different types of data structures. And again, there's a class called data structures that is simply dedicated to study what I just said. In this class, we are mostly only concerned with understanding the types of data structures that Java specifically support and can offer. Now, I understand most of you guys, or maybe even most of you guys, yes, I think all of you, came from a programming language experience of Python. Now, Python is a programming language that is known to simplify everything. One of the things that in Python, the first data structures that you learned in Python is a list. And one thing we learned about list is that it's a list is a collection of information. And in list, you simply can have many different data types in a list. Well, I would just have to tell you this. Whatever you learned about Python and data structures is simply not applied to Java. So have that experience from Python in your head, but do not try to apply it here because it's not going to work. So the first data type, the first data structure that we're going to cover is an array. Is it the only data structure available in Java and supported by Java? The answer is no. We have many different other data structures. Today, we're going to talk about arrays. Maybe in the next chapter, we're going to talk about array lists. And I am not sure, but I think we should talk about vectors as well with the array list, because they work as the opposite of each other. So let's focus on today's chapter, which is arrays. So what is an array? Array is, again, a collection of information that belong to the same data type. Very, very important. So this collection of information or data, all the data within this collection has the same data type. You cannot have multiple data types. It has to be a single data type. Now, what else do we need to know about arrays? Arrays and how they are organized inside the memory is a very, very important concept, because understanding how would your operating system create an array is a key factor here to understand why arrays are actually used and created. But there are, again, as I said, many, many, many topics that you need to know about arrays that we're going to go and talk. Details about arrays that you need to know. So let's start with this. How do I create an array? To create an array, you have to tell me what is the data type. That's the first thing to do. Tell me what is the data type. And then once you create the data type, once you know the data type, and let's go, for example, an integer, you add after that a square bracket opening and closing. Right after that, you tell me that what is the name of that array? I will call it, for example, name list. I don't want to use the word list because we have lists later, so let's call it name array. And I put semicolon here. Now, this is me creating the array. When I do this, what I'm simply doing, I'm reserving a space inside the memory, telling the memory that this area here, this memory location, that it's not a memory location, basically. Again, we'll see later that this is going to be a reference. Okay. So let me just put on the side, let me open a Microsoft Word. And I'm going to keep going backward and forward between them. So let me just switch my screen to Microsoft Word. So if that line that I just typed, when it's going to be interpreted, simply what's going to happen inside your memory, you will have something like this. So let's just put this all the way here. And now let's go back here and just say, when I typed, again, integer, name, array, what simply happened here, a space inside the memory was reserved, let's say this one here. And this space, again, at this point, has nothing in it. and we are going to refer to it as name array. Okay, so that's what's going on inside the memory. Now, after you create the array, this is again just us reserving a space inside the memory. After you create the array, you need to tell me, let me just go share my screen. You need to tell me how many elements do I have in that array. And to do that, and I want you to pay attention to what I'm going to do. I'm going to type the keyword new integer, and I will put a number here, for example, 10. Now, pay attention to new, because we use new every time we want to create an object. So that's telling me simply that an array is by default an object. So now by typing this, let me just tell you what's going to happen inside the memory. If I go back to sharing my, no, not this one. Where is it? Where's the Word document? Oh, I minimized it, so that's not going to work. Let me cancel this. Let's share again. Okay, now by telling the system that I'm reserving 5 spaces, what's going to happen? The operating system was going to search for 5 memory locations next to each other. They have to be next to each other. And again, when I say 5 memory locations, I really just, I mean that technically they're not 5 memory locations, because every one of those elements will have many different memory locations reserved for it. But just for simplicity, I'm just going to assume that every single integer will require a single memory location. So we got 1, 2, 3, 4, 5. Here it is. Those are my 5 memory locations. Now, what's going to happen here? The address of the first element here is going to be assigned to the array name array. So for example, if this memory location has an address of A2, 1, then A2, 1 is going to be stored here and is going to be referenced by name array. So name array here is a reference to those 5 memory locations where I'm going to store my values. Now, why is this important? It's very important because for us to have access to the elements one by one, we're going to use this memory location address. Now, actually, we're not going to use it exactly, but we're going to use some sort of mechanism that will give us access. Simply, you can use this memory location to have access to the first one. And then from the first one, you can move to the second one. And from the second one, you can move to the third one. And from the third one, you can move to the fourth one, and so on. Okay, so that's, again, how arrays simply work. Let me just stop sharing this one here, and let me move to the PowerPoint to show you how do arrays work. This, again, it's a phone list inside your memory. And again, you will have locations for each of those phones. And here it is. This is, again, something that I'm going to talk about in a sec, but that's just what's important for you to understand, that how the data is going to be organized inside the memory. That's the whole point here. This is how Java handle arrays. Now, let me go back to my Word document. So as you guys see here, my array is going to be stored inside the memory in this sequence format. Okay, and remember here, I'm using the keyword new to create the array. So everything we learned about objects are simply applied to arrays, and especially when it comes to a comparison between 2 arrays and using the equal sign and the double equal sign, which we're going to talk about later with more details. So with that being said, let's move on and go back to Eclipse. Now go ahead.
Wait, what is the difference between double equal and regular equal?
In objects,
Yeah,
again, in object, when you use a double equal, you're asking a question if those 2 objects are referencing the same spot inside the memory.
okay, so it works the same with lists?
What is that?
It works the same with lists or arrays, I mean.
Yeah, just like how you remember when we talked about comparing strings and how you're not supposed to use double equal to compare two strings?
Yeah.
The same thing is applied with arrays.
Okay, so there's like a method for it then.
We're going to talk about that when we get to that point. Yes. We have something called, special is going to be very, very special when we talk about the assignment operator. We're going to see that we have a shallow copy. We have something called a deep copy, and we're going to see the difference between them.
Okay.
Okay, so now that I have 10 spaces or spots inside the memory, the question is, what are the values of those spots? Okay, and the other question is, how do I have access to those spots inside the memory? Well, the answer here is very simple. What you can do, you can assign values to those elements one by one. How do we have access to them one by one? Well, we have a very, very special integer value called the index of the element of the array. And indexes usually, again, not usually, always start from 0 all the way to a number that is minus 1 of the size of the array. So in a case like this, the size of my array is 10 because I have 10 elements. That simply means I will have indexes of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are my indexes. And if I want to have access to any of these items and change their values, all I have to do is to use the array name, open a square brackets, and put the index and set it to a value. For example, 98. So if I go here and say system.out.print line, and I want to see what is the value of my, remember here, since we start counting from 0, so index 0 here represents my first element. So if I go here and put my name array, now it doesn't make sense to call a name since I'm not using names. So I'm going to go just call it my array. My array and my array. Now, if I run it, it will simply show me the value of 98 or 89. Now, what if I want to see the first element? Now, here you can see here, I assign manually the value 89 to the first element. So how about the second element, third element, and fourth element? Well, here's how Java handle it. And it's 0. So what's going to happen simply here, it means if I come here and put 6, I'll get 0. Whenever you create a value, an array, and you don't assign any values to it, Java will automatically assign the value 0 to all the elements of that array. So that's a fact that we need to know. So let's go ahead and copy this and repeat this for 10 times, actually. So there's going to be 1, it's going to be 2, there's going to be 3, there's going to be 4, there's going to be 5, there's going to be 6, there's going to be 7, there's going to be 8, and there's going to be 9. And here we go. Those are my 9 values. And now if I want to, let's change them here. I'll put 1, I'll put 2, I'll put 3, I'll put 0 here, I'll put 1 here, I'll put 2 here, I'll put 3 here, 4 here, and 5 here. Now, if I want to print them all on the screen, I'm doing this for a purpose, just to show you this is just repeated work. And we should have a way to get the job done without the need to all these repeating lines. 3, 4, 5, 7. Someone broke something outside of this room. I'll go and double check later. Let me just run it. And here we go. So those are my values. So inside my memory, there are, again, It's like physically there are many memory locations, but I'm just going to say every one of those elements here is going to reserve a memory location where the values are going to be stored there. So the first memory location is going to reserve this, store this, and this, and so on. I just need to go and double check on that sound that I heard, and I'll be back in a sec. Adam? 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 Okay? I heard something. Hey, I'm back. My wife is going to kill me when she's coming back. He broke one of her souvenirs.
Oh
Okay.
no.
Yes. A souvenir that we bought from Turkey when we visited.
Oh no.
Uh, I don't know. They look for something to break it. Anyway, okay, so let's go back here. What do we have here? We have this array that we created, and we said if we want to have access to the index of the elements here, we're going to use indexes. And as you can see here, with index 0, I assign the value 98 to index 0, 19 to index 1, and so on. And when I wanted to print them, I simply went through the process that you see here. Now, the question that I am trying to answer now, or sorry, the question that I'm trying to ask here, is there a better way to have access to the elements? Because again, here, this is a very simple case where I have 10 items. What if I had a million items in my array? Are you going to go ahead and write a single line for each item? That's not how it works. So here's how it works. And instead of us repeating those lines, and if you look at those lines, you would notice that you got this value here that changed all the time. Oh, you know, this value is going to change also, but we can have a mechanism to control what is the value that's going to be assigned to the element. So here's what we can do, and I'm going to show you that in two different ways. The first one, we use for loop. So we go with a for, and we know for loops. In the for loops, we're going to create an integer called I. You can call it IND for index, and set that to 0. Now, the IND or index is going to be used to hold the index values. And I'm going to come here and say I plus plus. So we're going to increase I every time we move in the process, or sorry, index, IND, because that's what we called it. And then most importantly, in this area here, we need to go and say, as long as the index is less than 10, because we have 10 elements, simply means we're going to start with 0 yes, 1 yes, 2 yes, 3 yes, 4 yes, 5 yes, all the way to 9. Until we get to 9, it's still acceptable. The moment you get to 10, that's where you're going to stop. And in this area here, what I'm going to do, I'm going to just type the name of the array. And instead of 0 here, we're just going to put IND, so we will have access to the indexes one by one. Now, at this point here, it's up to you to decide whatever you want to assign to it. You can have a scanner, for example, to assign a value to it. That's going to work. If you want to, that will simply work.
I have a question.
Yes, go ahead.
So there's no way to create an array and just have it created with like all the values already in it?
There is a way to do that. This is going to be my next point. It's called initialization, initialing an array as you create it.
Okay.
It's available. That method is available. That was going to be my next point. Okay, so what I'm going to do here, I'm simply going to use index, increase it by 1 and multiply it by 3. Actually, let's multiply by 3, yes, and put semicolon here. let me take, oh, how did I end up here? Oh yeah, now that's why. And you multiply this by 3. That's semicolon. Again, there's no specific reason why I decided to do that, but it's just a way so we can use random values assigned to this array. That's again what I'm trying to get out of this. Now to view the array, I can use the same thing here, but instead of, let's just go ahead and do the system print line, Control C, and put it here, and close this, and put semicolon. And that simply will print. So you can see here that I was able to get rid of all of that and replace it with a for loop. So for loops, in other words, are buddies with arrays. They work together all the time.
Or why don't you put the print statement inside the first loop instead of having 2?
I can do that if I want to.
Okay.
I just decided that for one loop, I want to assign values to the elements, and the second one, I want to do the printing.
Okay.
So if I run it now, you will see that 3, 6, 9, 12, and here it is. That makes sense. Those are the values. Okay, now at this point, again, there's no sense in what I'm trying to do as much as I'm just trying to demonstrate the syntax of arrays. Okay, so this is again how we create. Now, there's one problem with what I just did here, which is this value 10. We usually don't want to do that. We don't want to use magic numbers. So what we can do, for many reasons. Reason number one, here's what we can do. Let's say I don't know how many elements do I have inside an array. So instead of this, we can actually have a method called length, and the length would tell me how many items do I have in an array. Let me just make sure that, let's see here, one sec. Yeah, I could come here and say, let's say it's length dot my array. Oh, no, sorry, it's my array dot length, I think. Yep, my array dot length. Okay, so instead of me sticking with a number of 10, I'm just going to use, so if I change this one for, let's just run it for a second. And you'll see that I got this number. If I just come here and change this to 20, automatically the program will adapt to that. But there's one problem with what I just did here is that every time, again, you go in an iteration, this is going to be calculated. So we don't want this to be calculated with every single iteration. So it's going to be more efficient if I just come here and say, excuse me, size equal array length. My array length. And now you can replace this with the word, the variable size, and the variable size here. So that makes more sense, because otherwise, every time you go with the iteration, you're going to have to calculate the size of that array, the length of that array. And that's, again, a process that's going to take time. So it's just going to add complexity to your application. So this is, again, the basics of arrays. And this is how we create an array. This is how we decide how many values we have. In this for loop, I decided to go and assign values to that array. And in the other loop, I decided to only view the elements of the array. Now, let me move on to another way to create arrays. This time, and by the way, let me just go back here. Because this is an integer, the initial values that's going to be assigned to them are zeros. Now, if you have a double, that also will be zeros. If you have an array of objects, like strings, for example, those strings are going to be null. If you have an array of Boolean variables, by default are going to be false. So there will be always some default values that's going to be assigned to an array. Now, here's another way to create an array. I'm going to come here and create another array, integers. This time I'm going to call it my array number 1, and look at this technique at this time. What I'm going to do, I am going to simply open a curly brace and close a curly brace and put a semicolon here, and then I'm just going to put here state numbers. And that's it. Okay, so what is the difference between this one and this one? This here is me creating the array without initializing it. This is me creating the array, initializing it at the same time. Is it different than this one? Not that much. The only difference between them now is the size. Here, I decided the size is going to be 20, so I'm reserving 20 spaces here. The size is going to be reserved based on the number of elements that you typed here. So one time, you can actually set the size manually, typing it here, or you can actually do it this way. Now, of course, if I come here and just say system.out.print line, and by the way, just to let you know, whether it's this method or this method, this thing here is applied to both of them the same way. What I'm going to say here is my array 2.length, just to see how many items do I have. Oh, my array 1, not 2. And by running this, let's just put this back to 10. Let me run it. You can see here that I have 9 items here in this array. Okay, now, here's some facts that you need to know about Java that makes it a little bit different than other programming languages. In C and C++, for example, we create the arrays in a very, very similar fashion. The only difference between Java and C++ is the following. With C++, you have to put the square brackets after the name of the array, but with Java, you have to type them here at the beginning, after the data type. That would be number 1. Number 2, in Java, you can have this number to be a variable, and you can ask the user to assign a value to it. So let me just show you what I mean by that. I can come here and say integer size equal 10, and I could come here and just put size. And then if I do it that way, then there's no need for this line here. Okay. Yes,
sorry if this is going to be a point in a second. I was wondering, so can you do 2-dimensional arrays by just putting a comma between
2-dimensional arrays? It's simply array inside array.
Oh, okay.
Yes. And you can have a 3-dimension by having an array inside an array inside an array. I'll show you an example later when we get to that point. But I'll tell you something. I worked on a project in C++ where I had an array of 38 dimension. Believe me, when I was looking at it, I was just having a headache just to try to imagine those 38 dimensions and how did I put them together. It took the computer a week to process the data. Anyway, so here we go. As you can see here, let's just go back here. In Java, you can create a variable, and you can assign a value to the variable, and you can assign the size here as a size of it. And of course, I can have a scanner here to ask the user to tell me how many items you want to have inside your array, and then the user will simply tell me the number, and then the number is going to be used here. This is acceptable in Java for the reason that I showed you at the beginning, because with Java, when you create an array is a reference, and a reference simply means you're going to reserve a space to hold the address of the first element. And the moment you decide the size of the array, the operating system will go and look and search for the space for that array. In C++, for example, that's not acceptable because arrays are not references and not objects. So the moment you create an array in C++, you have to tell me exactly what is the size. And in C++, the only way you can use a variable for the size of the array if that variable was a constant. If it's a constant, you can use it, but it's a variable that can change, that's not acceptable. Again, this is just a point to know about C++ and how is it different than Java when it comes to arrays. So this part here, again, I can have a scanner here. You can use a scanner. You can use a scanner here if you want to decide what will be the size of that array. So here we go. This is how we create arrays. This is how we have access to the items of the arrays. This is another way just to show the items of the arrays. This is how we create another array in a different format. This is the linked method that would tell you the number of items that array may have. Okay, let's see what's next. I'm just following the PowerPoint that we are using to have an idea what we do. Creation, we talked about that. Creating the array, we talked about that. Initialization, we talked about that. Default values, the links property, we talked about that. Okay. Okay, now, sometimes we have arrays are partially filled. And this is, again, one of the issues that we have to understand here, since we're talking about this partially filled arrays. One big problem we have with arrays is the following. Once the size is specified, you cannot change it. Okay? Once you decided that this array will hold 10 items, inside the memory, there will be a space that will reserved for those 10 items. And at that point, you are not allowed to shrink it or extend it. That's a fact that you should know. So based on this fact, you have to ask yourself this question. What if I'm not sure about the size of the array? What if I'm dealing with data that could expand to contain millions or could shrink to hold 10 or 5 or 6 elements? If that's the situation that you have, then you should know that array is not your choice. Arrays are simply used when you know exactly what is the size of the array. Okay? And if you're not sure about the size of the array, we have different data structures for that. But what you should know that even though this could be considered as a disadvantage, you should know that array has a very, very important advantage over the other data structures that we may cover in the future, which is arrays are faster than any other data structure that we may cover in the future. So you can see here, there's always be some advantage and disadvantage of any specific data structure. Arrays specifically, once the size is specified, then you cannot go back and you cannot change it. The advantage is that arrays will give you access faster than the other data structures. The other data structures that we're going to cover in the future, they're simply designed to fix this specific problem of the size. And for them to fix this problem, they give up performance and they give up speed. So this is, again, the trade-off that we are dealing with here. So in cases, just let's imagine we are dealing with a scenario where performance is a very, very big deal for us, but at the same time, we don't know what will be the size that we have to deal with. In a case like that, this is what you can do. You can reserve a lot of spaces for your application, and you just have to estimate to know how far and how big your array can go, and then just reserve that space. Even though if you do that, you're simply going to be wasting a lot of space, but that's a price that you're simply going to have to pay. So once you decided to go with that way, now you're just going to be focusing on the elements that I'm going to be storing inside that array and how they're going to extend. So whenever you have a case like that, it's very, very important that you keep track on the last element you have in that array. So if I want to just simplify what I'm saying here, imagine this is my array. Let's say 1, 2, 3, 4, 5. And then let's just say the size of the array was too big because we were not sure about how many items we actually need in that array. In a case like that, we know the first item, very, very simple, start with an index of 0, but it's very, very important for you to keep track on the last item as well. So what you need to do, you need to create a variable to track the last item. And every time you add a new item to your array, that index should be moved to the next point. So you can be able to track the first element and the last element in that array. So again, when you want to process the elements of the array, you really don't need to go through all the elements. You just have to go from the first one to the index of the last one. So that's, again, what we mean by partial filled array. Now, in reality, I'll tell you, if you are dealing with a case where you're not sure how many items you will have, and you don't know if the size of the array of the data structure could be expanded, could be shrunk, then probably arrays is not your best option. So this is one thing I needed to tell you about. And before we talked about copying arrays and assignment array and checking for equality of arrays, let me go and move on and talk about the for each that I was talking about at the beginning. Now, you can use while loop and do while loops with arrays, but I will say do not do that. Technically, you can, but that's not a good option. With arrays, your best choice is for loop or for each. So this here, I showed you a case where I used a for loop to assign values to an array. And this is a for loop where I showed you a case where I'm printing the items of the array. We have another case or another type of for loop. It's called for each. And the for each goes like this. For integer x, and I will just, what did I call it? I called it my array. Okay. And if I go down here and I'll just say print, so I'm teaching Python in the morning, so Python keeps jumping. And print x here. This is what we call a for each loop. And you can see here it's different in the syntax of this one. Now let me just explain what do we have here. With this for loop, we have an index I that will be compared to the size. And as long as index I is less than the size, we're going to do whatever you wanted me to do here, which is in this case to print my array at index 0. And once you're done, you're going to increase the index by 1, and then you're going to come back and compare it to the size. If this condition is still true, you go ahead and print the second item, and you keep going that way. The for each works in a different way. What are we doing here? Think about this. This part here is simply you're taking every single item of my array and you assign it to x with every iteration. So with the first iteration, x is going to be holding the first value, the first element. With the second iteration, x was going to be holding the second item. With the third iteration, x is going to be holding the third iteration item, and so on. So you would notice that this part here that I'm highlighting is going to be repeated again as I'm going. So let's go ahead and do that. And let's just go up here a little bit. And here you go. Where is it? Here we go. So 30. And then after that, we started again, 369 all the way to 30. So now at this point, you should ask me the question. Come on in. Here you go.
Thank you.
Welcome. Close the door.
Okay.
Okay, so let's think about the differences between those two. As you can see, the result is exactly the same. The different here, and this is something you have to think about, and you just have to follow this piece of advice. Let's just put it that way. For each work faster than for the regular for loop. So that simply means, should I just use for each every time? By the way, it's called for each, or it's called a smart for loop. Those are different names for it. But the idea here is that, let me just put it this as clear as possible. If your whole point is to have access to the items without processing the items, then you go ahead and use the for each. If your goal is to process the items, manipulate the items, change the items, then this for each will not work. Because what you're doing here, you're assigning a copy of each item of the array to X. And here you're printing X, you're processing X. You're not changing the original value of the array. And because of that, for each or smart for loop is not useful when it comes to manipulating the elements of the array. It would not work. If you want to manipulate the elements of the array, you have to go and use the regular for loop. But if the whole goal here is just to show the items of the loop, of the array, then this for each will be a good choice. Okay, so with that being said, let me see here. Copy the arrays, searching the arrays.
So if you can't change or like manipulate elements in an array without the index value, then
Yeah,
why
you have to have access to them by the index value.
Then why use the for each?
You cannot use for each if you want to do that.
No, I'm saying what are the benefits of using for each?
It's faster.
Okay.
I'll just let me put it this way. If I have to use between this one and this one, go ahead and use this one. You see this for loop here that I just created to have access to the items to print them. And I'm doing the same thing here using two different techniques. If that's the case, you go with the for each. Is that clear?
Yeah.
Okay. Now, I do have like 3 minutes left. Let me just see. Sorry, not 3 minutes, 15 minutes left. Let me see if I initialize the post length.
Could you make a counter variable to like increment every time the for each loop goes through?
Well,
To track
you can, but what will be the point of that? I'll show you. I think I know what you're talking about. If I come
Yeah.
here and say an integer C and set that to 0, for example, and here I will say my array, Control V. Okay, where is it? Of C, wait, let me go back here. Of C, for example, equal C plus 2 multiplied by 10. And let me see. This is me trying to change it, of course. And then after that, of course, C plus plus. You can do it that way. But again, there's no need for all this. If your goal again is to manipulate the items of the array, just go ahead and use a regular for loop.
Okay.
Mm-hmm. Okay, let me take that out. Now, the last thing I want to talk about today is let me see here. How do we copy an array? That's again a very, very important concept because in general, we have two different types of copies when it comes to data structures. We have something called a shallow copy and we have something called a deep copy. And what you should know that arrays in general, they use what we call a shallow copy when you assign a value to a value directly. Okay. So how do we copy arrays? Let's see here. I really don't want to start that right now. But let me just go ahead and just demonstrate the concept. If I come here, let me just show you this. If I come here and say integer, I'm going to get into the details of this when we start our next class. But if I say integer, for example, x1 equal new, well, let's go ahead with actually 1, 2, 3, and 4. Okay. And if I say integer, let's call this one x2. And if I said x2 equal x1, I want to ask you a question now. What's going on inside the memory when you do something like this? The answer will be, let me just go and share my Word document. Oh, why is this turn? Okay, it's getting dark. Okay. What's going on inside the memory? Let's just go ahead and start a new page or Control A. Let me move to here, this area here. Let's go ahead and insert. Why are you going back here? Okay, let's go ahead and do that. Let's minimize it a little bit. And let's go ahead and split. I'll only have one column with 13 row. No, it has to be 5. That's weird. 5. It is weird. Let me just go ahead and create a new one. Okay, let's do the same thing here. 5 again. Let's do the same thing here. And 5 again. Okay, so when I decided to create an array and I called it integer, let me just type it. That will make it a lot easier. If I, where is it? I don't want to. Okay. Integer. Call this one x1. And we reserved 5 values, 1, 2, 3, 4, and 5 inside the memory. We simply reserve the space here. We're calling it x1. And we reserved 5 spaces inside the memory. Let's say they're 1, 2, 3, 4, 5. And this one is going to hold the value of 1, 2, 3, 4, and 5. And let's just say the memory location of this variable, first element is, let's say it's A1. So simply A1 is going to be stored here. Now, when I created a new space and I called it x2, and I came here and said integer array x2, and I said equal x1, I am simply taking this A1 and I'm assigning it here. So what's going on here? x2 is referencing this area, and x1 is referencing the same area. So when you use this single copy, we are doing what we call a shallow copy. You're not copying, you're not reserving 2 spaces inside the memories, one for array 1 and one for array 2, where array 1 is 5 elements and array 2 is 5 elements and they have identical values. That's not the case. What are you doing here? Simply, you are referencing the same spot inside the memory by 2 identifiers. So when you come here and say if x1 double equal x2, you are simply asking if x1 and x2 are referencing the same spot inside the memory. In other words, you're comparing this value to this value. And that's how arrays work in Java. That's again what we call a shallow copy. So again, you are not making an actual copy of that array. You're simply making 2 references to reference the same spot inside the memory. Now, the question that you may ask at this point, which is, how do I actually have a deep copy? Well, Deep copy could be achieved using different methods. One of them, you can do it yourself. It's a very simple and easy process. And let me just go and show you that. Yeah, I do have time. Let me just go ahead and do that. And that will be the last thing for the class of today. What I'm going to do here, I'm going to say new integer. And I will reserve, let's say, 4 spots for it, semicolon. And in this case, I'm going to say for, look at this, very important, integer I equals 0, I is less than 4, I plus plus. And in this area, this is what I'm going to do. I'm just going to say x2 of I equal x1 of I. So what am I doing here? I am actually going element by element from array x1, and I'm assigning them to x2. And in a case like that, you will notice that when you type x1 equal x2, in this case, it should be false. So let me just, before I continue, let me just put this as a comment, and let me just put this as x1, and let's go ahead and print system.out.print. This is something that they need to change about Python, about Java. This system out.print line, just put one word and get it over with. So x1 double equal x2. Let's just run this and see what's going to happen. At the bottom, it is true. Now let's just change this to make it new integer. And let's put 4 here. And let's take this one here and this one here. And let me copy this, or cut it actually, and put it here. And let's see if actually this is going to work. And now you got false. Even though they hold the same exact values. But again, double equal, when you use it with arrays, simply implies that you are asking if both arrays are referencing the same spot inside the memory. I will leave this to you to go and do a research about how do you check if you want to just check if 2 arrays are exactly the same. There should be a method for that. Now, before again, I let you guys go, if you want to actually get the job done with this for loop, we have some methods. One of them is called array copy. In array copy, you have to give me the first array that you want to copy from, and you tell me what is the first element you want to copy from, the index of the first element, and then you tell me what is the array you want to copy to, and then after that you tell me where you're going to start copying with index of 0, and then after that you tell me how many elements you want to copy. Let me just show you. Instead of this one, you can type the following: system dot array copy. And look what I'm going to type. I'm going to type here. Did I misspell anything? No. You're going to have to tell me here. X1, starting from index 0, X2, starting from index 0 dot X1 dot length. That simply is equivalent to what you see down here. Another way to get the job done is simply, if I take this one away, and let me comment this one away, and I'm just going to come here and say integer x2 equal, let's just go back here. There's no space here. X2 equal a1 dot clone. And now, sorry, not a1, it's x1 dot clone. So this here is equivalent to what you see here. Those are different methods to copy, or you can do it manually, as you can see here. Next class, we're going to talk about how do we compare arrays. We're going to talk about the search, the sort, and many other operations. Let me stop sharing. Let me start recording.